Your Excellency, dear guests, good morning. It's an honor to welcome you to this session. The title of this session is Deep Learning for Deep Seas and Innovation in Ocean Research. As we know, the ocean is covering more than 70% of our planet, which made it the least explored frontier. Pretty much in the recent years, we started to really realize that AI is transforming our way of understanding how the deep sea, through different technologies, such as the autonomous underwater vehicles, predictive climate models, or marine biodiversity. But technological innovation themselves are not enough. So we see the governments play a critical role in making that impact, especially ranging from the funding the AI research, setting the regulatory frameworks or policies, or even playing a critical role in terms of the collaboration through the different stakeholders, such as the private, public, and also the philanthropic, as we have heard from the previous sessions as well. Today, I'm joined by our distinguished guests. I'm going to introduce them to you right from left side. Dr. Vincent Pieribone, CEO of OceanX USA. Nice to meet you. We have also Dr. Prashant Marpu, VP of R&D at Bahamas, at Bayanat. We also have, nice to meet you as well, we have also Dr. Hosni, Professor of Practice at Mohamed Zayed University of AI. Nice to meet you as well. We have also Her Excellency, Dr. Shaikha Al Dhaheri, Secretary General of Environment, Abu Dhabi. Lovely to meet you. So we start by diving in, actually, with the first question. Start with you first, Vincent. So what are the key ways AI has improved our ability to explore and study the ocean compared to the conventional methods?
Terrific. Well, thank you, and thank you for inviting me here. I think on a top level, I think of the ocean as a very, very complicated system, a system that involves biology, that involves oceanography, chemistry, weather, climate. And because of that, I think it's a system that is intensely complicated, and it makes it difficult for humans to conceptualize how to use that model or how to create models in the old-fashioned way to predict future states. So to me, the largest impact it will have and is beginning to have is in modeling large systems, the concept of sort of digital twinning, the ability to get enough information from these different domains and then ask these models questions, because AI is so good at creating algorithms from very complicated data. But on a very practical level, we use it daily for image recognition of organisms in the deep. We use it for studying the piles of genomic data that we create. And we use it to help us accumulate and analyze and predict where we might find things in the ocean, because the ocean is very difficult to find creatures, to find systems. So to me, it's a revolutionary approach to the ocean.
Thank you, Vincent. Now, it's the same question will be answered by you, Vincent, as well.
As Vincent said, oceans are very complex. We barely are scratching the top of what we know about oceans now. With data being collected. First of all, there's no data available to even understand what's happening in the oceans. And these are very interconnected systems. What happens in Pacific, for instance, affects what happens in Indonesia and all those things right now. Things are changing so drastically. And we are being represented by, life is being represented in the ocean. Now it's like, that's the maximum we have on Earth in a way, compared to what we have on ground. Basically, ocean caters to majority of the life forms we have on the Earth. Now, when things are changing so drastically, to understand what's happening out there and trying to collect the right data and putting that together to make sense of the data, you definitely need to deal with large AI systems. We are still not even at the beginning of that era, basically, because we are still trying to collect information to collate sufficient meaningful data there to be able to apply AI algorithms there.
Thank you. Dr. Hosni.
Thank you, Dr. Mohamed. Just to add what Vincent and Prashant mentioned, so the complexity of ocean require like multidisciplinary actions, and the AI Now, with the recent revolution, what's going on in AI field, like ocean science and the climate in general is benefiting from it. So in addition to the modeling capability, in addition to the big data and analytics, I see autonomous system is very important, robotics, UAVs, like marine UAVs, how we can, now this technology is getting cheaper, and then with AI in terms of capability of process, like computer vision, how you can identify species, how we can scan, because ocean is covering more 70% of the planet surface that require tremendous resources. And this is when AI play a role in this. Imagine that we have those different autonomous systems like scanning the bathymetry, scanning different areas that a human never reached before, and collecting all this data, all these images, all the terabyte of data collected in real time. This is where AI can play a role in terms of fusion data from different sources. It's the data fusion, it's part of computer vision. The machine learning part can contribute in processing, predictive, and simulating scenarios. And the modeling part, I see the climate modeling is very important. Now the AI is being more and more used in climate modeling and forecasting. We see it very successful in weather in season to season, but also long-term climate. The AI start positioning itself as one of the key tools used in this field that ocean will benefit directly out of it.
Very good, very good. And Your Excellency, Dr. Shaikha.
Thank you, Doctor. I think I will talk about how AI is transforming us from the 27 years of experience that I personally had. One, as I started as a scientist, and I used to be, and also this is on behalf of a whole agency that started the research in Abu Dhabi, and specifically we were interested in the marine domain. So the conventional or traditional monitoring or researching definitely have a huge cost, definitely depend on a huge and large number of manpower. Definitely it's slow to find out what is happening. And it has lots of limitation, risks to scientists, researchers in the field. I broke my nose one time surveying the cost. So AI in the last 2 years for Abu Dhabi agency, environmental agency, and working with Vincent and working with Prashant have showed us the huge capability that can provide as a technology. One, the scalability. It's much bigger than the traditional. It's much faster, and it is more predictive. And this is what we need, prediction, because with the traditional ways of collecting knowledge and data, we lose time to react. We are reactive and not proactive. So I believe that the AI is gonna help opening a lot of domains and a lot of understanding, not only to the oceans, but to many, environmental ecosystems and beyond.
So I see here also a mutual collaboration, as you touch base, the collaboration between you and Prashant and maybe Barisa project. So in such collaboration, I think this is also the same common, dilemma, or the biggest, most pressing challenges where in applying AI, usually you face a lot of, challenges, especially the challenges that is also surrounding the implementation of AI systems. So from your experiences, can you shed some light about those challenges you already faced? Start with you, Vincent.
Yeah, I would say it's three things: data, data, data. And because the ocean has these characteristics that people maybe don't think as much about, a lot of the modern revolution in sensing, the ocean can't take advantage of, because no radio waves underwater, no GPS, no Bluetooth, no Wi-Fi, none of that works underwater. Yep. So to position, even to find what position you have, and you have a three-dimensional space that you need to be in. So it's very challenging to put autonomous vehicles in the water. In fact, mid-water column autonomous vehicles can't find their way. Yep. They don't know where they are. So it's hard to collect data, and it's expensive, and it's deep, and it's high pressure, and it's saline. So we need cheaper, faster ways to collect a lot of data. In the climate world, we have remote sensing, which is great. We can collect reams of data just by looking down on the Earth. It's also because the refractive index of air is very high, and you can see with the satellite all the way down to read license plates, but you can't do that in the ocean. You can't penetrate with remote sensors, and even if you have water-based you have maybe a few meters of visibility. So you have to get very close to your subjects on the bottom. So we need new ways to study, new ways to collect the data in order to feed the AI so we can start getting the answers.
Good, thank you.
Adding to that, it's like the heterogeneity of what we see out there is huge, right? It's like what works in one region doesn't work in the other region. So you have to collect much more data than what is out there, basically, because if something is working in the US waters, for instance, it will not work in the Arabian Gulf, right? So that's the other challenge. And then there are these interconnections that we need to look at, right? For example, we are trying to work on developing methodologies for fisheries surveys in the waters, right, which is very crucial. We need to understand where the fish is, where you have to have protected areas, for instance, to protect the fishes and so on. So then you have to understand a lot more things. Now you need to combine from the top, the surface properties, the habitats, then genomics data, for instance, to understand where the fish are moving, for instance, right? It's one example I'm talking about, but you see how many things are coming together. Now, then you also have to look at other things. The transfer of nutrients, it's like this region recently has seen increasing dust storms, for instance, right? Because of land becoming dry in other parts, closer to us. That's carrying more and more nutrients. Carrying more and more nutrients means that, it's like the algae on the surface is also increasing, which is detrimental to the fish. Now, when you want to understand what is happening out there, even in a small water body, relatively like the Gulf we have, you have to consider so many of these factors and understand what is happening below to just relate what is happening to the fish, right? So these two factors, trying to figure out the root causes and the context and dealing with the heterogeneity, these are two major challenges. And as Vincent said, you actually need more and more data to be collected and curated in a proper way so that the AI can take over and start doing its work.
Yeah. You highlight a very interesting point. I think there is also a consensus here, the agreement on the data limitations, as you highlighted, Vincent, as well, but also to have the AI-ready data. Say the AI-ready, the curation of data, as you mentioned, labeling, the annotation, the availability of the expert, right? So from the data perspective, the science perspective, who are going to really work and do the annotation work to make those AI systems run at large scale. To you, Dr. Hosni, what do you see those biggest challenges, the most pressing ones?
I think definitely data is a big challenge, but not just data, the quality as well. Because ocean are huge, so the data collected from different sources, different protocols, to make sure there is a huge effort in international community to have the same norms, normalization of data collection protocols. And this is the challenge, especially when we try to process large scale and to run model in large scale area. But I think this is the main challenge. The second challenge is to have this expert would have both computer science and oceanography background, because we have people talking different languages. So how we can, and this is the role of our academic institution to train students with this interest, to have very strong AI, computer science background, but also very strong interest to apply this knowledge in area like oceanography and ocean science in general. So the challenge, the main challenge is the data availability, but also data quality, and also having this mix of expertise that can work together, identify the main issue that we can take advantage of the capability offered by AI presently.
That's indeed very significant point. Back to you, Dr.
I think it has been said a couple of times by the panelists, and I would repeat it again. Data. Today, ocean data is very sparse, so we need to really collect more data. If we want to move into AI, the AI system or tool, and Prashant and Vincent know better than me, that it will need to eat a lot of data to be able to be trained, to reach maturity, and so on. The second challenge, today most of the technologies are expensive. So the affordability of the equipment, sensors, UAVs, whatever it is, need to reach a level of shelf purchasing in order for every researcher and scientist to afford, or institute to afford adopting the AI. The third point, the ocean is a complex system. So it will depend not only on the data that we collect around fisheries, bathymetric data, whatever it is, but also other components that might not sit, for example, today with the Environment Agency. So integration of different sectoral data within the AI system gonna help fast track and accelerate that maturity. And I would like to shed the light on the Environment Agency experience in the last 18 months. We did commit in front of our board that we will transform 100% of our core businesses into AI and technology-based. This is a huge commitment, but we understood that if we don't take that bold action 18 months ago, it will be coming to us fast and we will not be ready. So to be ready is a very important element. Most of us in the Environment Agency, either researcher or policymaker. We are not AI specialists. And what I want to say is that even though we collaborated with the experts, Bayanat, M42, OceanX, I think this collaboration is not enough because we need to build the capability and build the capacity within the researchers to become marine specialists, but also technology and AI specialists, and the other way around as well. The AI specialists need to understand what they are dealing with in order to help accelerating that development. We worked with our partners to move from traditional monitoring of fish landing, which is a very intensive process that takes daily on every morning by almost 15 staff. With the help of Prashant and his team, we converted this process from conventional into AI-based. So we cut down on the time by 80%. We cut on the resources as well by 80% through a process of face recognition of the fish, each type of the fish, but also giving the AI the ability to do certain processes that were taking place in the lab and might take 3 days. And now it takes on the spot, like defining the age of the species, taking the length of the species, and many user cases that we developed with them that now they are 100% complete. But again, we are not celebrating their completion. We need to celebrate their efficiency, their accuracy, and their precision in collecting the data and giving us the recommendation and the prediction that we expect from these AI tools.
That's a very interesting, actually, initiative and coincide pretty much with my next question as well, which I'm going to ask all of you, which is your organization, when utilizing AI, what impact it really made? Because if you heard, like, a couple of weeks ago about the black devil fish that rose up to the surface, I mean, the question that really arises, what are the reasons that attributed to that? It could be different reasons. So that's one of the examples. I mean, so I give you the floor, Dr. Vincent.
Well, in sort of on the ground, immediately, it's sort of image recognition for us and protein design, which is an odd thing to mention in an ocean discussion, but a lot of the proteins that we're designing are proteins that come out of the ocean. We're designing future proteins from studying the ones that are in there. So acutely, actually, that's something that our team, our people have found. So we collect hours and hours of footage of various remote underwater scenes. We did it here in the Gulf, riding around with ROVs and deep sea submersibles, recording hours and hours of video. And what that generally requires is days, weeks, and months of experts, which are hard to find, looking at it and saying, oh, there's that type of coral, there's that type of sponge, there's that fish. And AI just makes quick work of that. So once you have training sets of data for image recognition, as we were saying, it's quick work. So we can go through thousands of hours before we even get off the boat. And so that is there's thousands and thousands of hours of footage sitting all over the world waiting for AI to hit it. So practically, it's a lifesaver for those of us trying to determine what's out there in the water. So practically, that has sped up our ability to assess ecosystem complexity and diversity and change unimaginable. So that's sort of already in action.
Very good point. Very well. Back to you also.
Yeah, just to echo Her Excellency's words, basically, it's like efficiency improvement is one of the first drivers to start this work, right? There's so much footage that was collected in a way, underwater or other data sets and so on, right? And just because it was always the expert sitting and trying to understand what is happening, it's a slow process. It takes a lot of time to complete those things. And at the same time, advanced technology implementation or usage is delayed because you're stuck in the protocols that were established based on these things, right? So if you allow experts to spend less time on manual work, but actually explore using new technologies to gather more information, it drastically improves the entire efficiency of things, right?
So what you need in that case is actually the high quality data plus the SME, the subject matter experts, which gives you the AI system. Right?
Yeah, but also adaptation of new technologies, right? Now this is what OceanX was doing, and this is what we're trying to do, EAD is trying to do as well, right? Now, instead of spending time on looking at video streams, for instance, and trying to label and count and all those things, AI will do that for you. Then you can explore other technologies. For example, we had a very nice discussion with Vincent on exploring hyperspectral technology underwater in a way, right? If you're manually looking at this thing, hyperspectral technology doesn't make sense at all. You need a system, computer system, to actually understand what is happening there, no? They could do that because some other work is given to AI.
Yes. Yes. So from automation to autonomy. Doctor.
So from our angle as academic institution, so at Mohamed bin Zayed University Artificial Intelligence, so we are building now this research cluster on climate science, energy transition, and decarbonization in general, and maritime and marine science and ocean science is part of the application that we envision to train our scientists. Because the idea is to leverage on our in-house capability, because we are one of the largest research universities in the world. We have more than 600 scientists in AI, in computer vision, machine learning, autonomous systems, robotics, human-machine interaction. So we have all those expertise, but are more into theory, but we are pushing now to move to the applied science, how the community like oceanography or marine community, environmental agency take advantage of those unique capabilities. So we are also working on adaptation of those science to our local and regional environment. So we are surrounded with high saline water in the middle, in the Arabian Gulf. We have very challenging situation where all our drinking water is coming from desalination, so the input of those desalination plants coming from the open water that is very vulnerable to the surrounding condition. As you know, like 20 million barrels of oil navigating next to the UAE shorelines per day, 20 million per day. All most of the export of Saudis, all the other Iraq, Kuwait, Qatar, all the countries are exporting their oil from the Hormuz Strait and navigating through next to our shoreline. So how we can protect our intake of desalination plants? For example, for any accidental oil spill. So how AI can play a role in combined by hydrodynamic modeling with the satellite data to be able to assimilate real time. We are talking about hundreds of gigabytes of terabyte of data coming from different sources. So it's where we are pushing our scientists in from the computer vision, from data fusion, from digital twin for the whole Gulf ecosystem to be able to be responsive and predictive in terms of
very interesting. You mentioned about the satellite data and also the high frequency, the low frequency of the data. It's very essential actually to have it part of the ecosystem. So we still have like 2 minutes to go, but maybe to give you the floor again, Dr. Shaikha, to shed some light about the impacts that your organization really made, when utilizing the AI.
From a government perspective, it's adding a lot. And as a decision maker, I felt more and more day after day that we don't have the time to wait for, and I'm a scientist to give me the data I requested. Nevertheless, when we talk about our decision makers requesting a certain information, and that's have driven us as a regulatory body to make sure that we integrate a real-time data. It is very much important to be available at different level, decision makers, our level as government, probably the private academia, and also other level. This is one. The second, as a government, our budget as well, and I will be frank here, will not expand. So how we can be more efficient with the same resources? AI was a tool to free some of the resources and divert them into expanding the scope. If I remain business as usual, I will be limited in covering the same scope that I have been covering for the last 10 years. With the adoption of technology, innovation, and AI, I was able to free some of the resources, whether it's budget or manpower, but still expand my role in the canvas of the environment in Abu Dhabi and beyond.
Thank you, Dr. Shaikha. I think we still have like few seconds left, but I can do a quick recap actually on the closing remarks. So we have agreed, we have a consensus and agreement is that there is these challenges, the biggest and the most pressing challenges with surrounding the implementation of the AI, ranging from the data limitation, the infrastructure, decision-making policies, also the availability of the data, not only the data, the high quality data, the AI-ready data for the system to be implemented. You mentioned also about the availability of the researchers, the skill sets, the talents, upskilling, skilling those talents to really be prepared and be able to really work on these large-scale AI systems. With this, I thank my distinguished panelists, and I thank you all for being part of this significant conversation. Thank you all.
Thank you.